I'm a graphics engineer. Been making games since 1999, give or take. And I always wrote my graphics engines. The big takeaway for me here is that first, I don't have to do it anymore. I can just write the shaders. I can just write the fun part because Unity helped me with all the legwork. And we're going to talk about, first, all the editor and workflow improvements that Unity is bringing to the table recently. Unity has been really, really good at presenting in the editor how the game looks like. I worked on games where the iteration time was something like, I make a change, not me, but the artist, make a change in the level, compile lighting, 2 days later, see how it looks like. Well, in Unity, that's not how it works. You can see immediately what the content creator is working on. But now Unity is getting better and better at also showing on device how the game looks like. I'm a huge fan, and I always ask all my content creators to look at the game on the device, because a model, a texture, a level might look wonderful on your Photoshop or on your 3D package, might look wonderful on the editor, but the device is a different beast, a different monitor. Everything is different. Just check on device, and Unity is helping here as well. Iteration is key, and Unity makes it as fast as possible. Then we're going to talk about graphics, which is my favorite subject. So I'm a graphics engineer. And here, Unity is bringing to the table the possibility to address the whole range of devices, from low-power devices, low-performance devices, to high-end devices. It offers low-quality renders to address these low-end devices, and high-fidelity renders to address the high-end AAA kind of use case. And finally, at the end, we're going to talk about Google Play support and how we're writing, as Google, our own plugins to help you develop and ship on Android. So I'm very excited to leave the stage to Jesse from Unity. Thank you.
Hello, everyone. So glad to be here today. So my name is JC. I'm a product manager at Unity. I focus primarily on mobile platforms. And yeah, I'm going to talk about Unity. And before I get into there, I just want to do a quick raise hand. So who's using Unity currently? I saw a few people who didn't raise their hand. What are you doing? Come on. There's a free version to try. No commitment, just try. It's easy, get started. So more seriously, Unity started more than 10 years ago with a vision in mind, is that we wanted to democratize game development, really help creators to realize their vision. And since then, well, a few million users have tried and used Unity and keep using Unity. But also, we've gone beyond games. So Unity is also now powering other industries like film, automotive, simulation, architecture, and many more. And this is because basically our technology is a real-time 3D engine, 3D development platform. You can do 2D if you want. It's just removing one dimension, which is fairly easy. So, and Unity's focus at the beginning was really on the creator, helping you to realize your vision. We've always thought that the world is a better world the more creator we have. But we've also realized that creating is only one thing. You want to go to the next step, and the next step is when you create for serious, you want to make it a business, and you want to live from that, we're trying to enable success. And the way we do that, we offer additional options for Unity users to basically manage the lifestyle, the life cycle of their games. And in particular, we offer a service to manage multiplayer. So if you want to create a multiplayer game, we have all the things you need to do with Unity. And finally, on mobile, if you choose to monetize through advertising, for example, we have also a very strong network that can be used to help you be successful. So just a very quick intro to give you a sense of Unity is not just a game engine, it's actually way more than that. But today, we're going to focus on the creation part. And as Fran said in the intro, we're going to start looking at workflow improvement. And I want to remind some of the goals really that are critical to go. So first of all, I didn't mention it, but one of the key things in addition to democratizing game development is also to be a cross-platform engine. Basically, you build once and you deploy everywhere. And I'll be honest, deploying everywhere requires always a little bit of work, but we're trying to make that work as painless as possible. The second thing is about general productivity. We want to give you the tools that makes you go do things the fastest as possible, and we'll go through a few of those new things. And iteration on device is really core to the investment we're making these days to help you work in the editor, do things really fast, but also being able to see the result of your iteration, your work on device. Because yes, mobile devices are a little tricky, and there are many, many kinds of devices in the Android ecosystem. The diversity is so broad that testing on device is definitely a must. So I'm going to go through a list of features that are coming or just landing in Unity and try to give you a sense of the latest and greatest that are helping in those areas that we mentioned. So first of all, in 19.1, we're now shipping with Unity the correct Android SDK, Android NDK, and actually starting with 18.2 or 18.3, starting with the last version of 2018, we included OpenJDK, so which means now when you install Unity for Android and you've done with the installation, you can actually build and deploy right away. You don't have to do any configuration. It's ready to go. And if you're an advanced user, you know what you're doing, you can actually do more advanced configuration and set things up the way you want. But to get started really fast, that's built in via the hub, which is the new way to install Unity and get all the different components. In 19.2, we're working on a new feature to enable you to manage notification from Unity directly, so you don't have to deal with the low-level system operations. And that's a way to do cross-platform notification for iOS and Android. It's going to be delivered as a package, and it's in preview currently. So I didn't mention in 19.1 the safe area and the notch because I have a special slide for that. So starting with Unity 19.2, we are adding the feature that enables you to detect the cutout area. And the safe area is where you can safely place content. It's not going to be behind a notch. And so now via code, you can actually detect what are the different areas. The safe area, no problem. It tells you where the cutout is, and then you know where the space is. So by the way, do you know what phone that is? Nobody knows? Nobody want to guess? OK. So that's a Pixel 3 XL. So if you're running that code, actually exactly that code, on a Pixel 3 XL, this is what happens. So the first thing, you start by defining your screen safe area, and that's a red rectangle that's been drawn here. And then you define a variable that is the cutouts, and there can be multiple cutouts. And you do a simple loop. You check that there's at least one cutout, and if there's one right here, we're drawing a green rectangle. So this is really super easy to use and very convenient if you want to maximize the space that you have on your phones. And by the way, that feature also works on iPhone, so you're going to get the same code working across platform. Profiling, it's always challenging. When you make a game, it works well on one device, and then on another device, maybe it doesn't work that well. So there's a lot of profiling option. Unity has a pretty advanced profiler that allows you to look inside the game from Unity standpoint. But what we've done with Unity 19.1, we've actually instrumented the build that we make. So when you run a Unity game on Android, Systrace, which is one of the advanced profiling tools, will actually know inside the Unity app what's going on. So on that screenshot, it shows from Systrace, which is a native Android profiling tool, what are the different threads in Unity? What is a rendering thread? What is a main thread? What is a choreographer? And so you can detect from the outside what's going wrong, or what are the problems potentially that could be caused by some interference with other applications running on the system, or some weird thing that you cannot detect from within Unity. So super useful, and that's available now. So another more advanced way of debugging is using Android Logcat. So very powerful, very verbose debugging tool. What we've done is actually we brought Logcat inside Unity, so you don't have to do any command line tool. And it's also super useful because we give you a lot of information that you can filter and look through. So I have a little scenario here. So this is a Logcat window running inside Unity. So once you've connected a phone, you're going to start seeing all the Logcat event coming to Unity. And of course, that's maybe a little too much. So the first thing I'm going to do is filter, and I'm going to filter by the application that's running on the device. So I've deployed this little game, and so I'm going to just select this one. And now the Logcat gives me only the events that are generated by this application. So in this case, this is the legal card game. And as you can see at the bottom, the deck of cards is empty, and obviously something wrong happened. And yes, this is a game that's using asset bundles that are hosted somewhere else. And I forgot to make my build to build my assets. So the game starts, try to download the assets. The assets are not here. It generates errors that you can see directly in Logcat. So in that case, I can detect very quickly what's going wrong and then fix it really quickly. And by the way, the screenshot is also taken directly from Unity. There's the little button here, capture screen. It's going to take a screenshot of what's running on the device, and you can save it locally on your machine. Small feature, but super convenient. So now, when you're deploying to your device, you always try, and then you want to make a change. So we've introduced a new feature in Unity 19.1 for Android that allows you to do super fast iteration on code. So here's a scenario. So the video just started. So we make a build. So we have a little sample game. You may have seen it. This is one we're using in our teaching material. It's Infinite Runner. So the first build takes about a minute. It was a little fast. So the score starts at 0. And I like to cheat. So what I'm going to do, I want to change the code and start the game at 10. So I'm going to the code, going to do a little quick change. And at this point, I don't want to rebuild the whole game. So what I'm going to do, I'm going to use this option script only. So I'm going to recompile just the code, not touch any asset. And I'm going to ask Unity, OK, rebuild the code, recompile the code, and just push the new library. And so in this case, I don't even rebuild a new APK. I just recompile my library, push it to the device, and it takes 18 seconds instead of 1 minute. And as you can see, when I restart the game will look for the new library and take it into account. And then, as you can see, I cheated. Now I'm starting with 10 points ahead. It's available in Unity 2019.1 that shipped last week. And that is really fast when you want to do a code iteration on your code only. AR. So who's doing AR development in the room? A few. Great. So one of the key things is very focused on our desire to provide cross-platform support. We've brought AR Foundation, which is a new layer in Unity that really gives that cross-platform feature across iOS and Android. But also what we're doing is by giving you this kind of common APIs to do all the common things, we're also providing some extensions so that every platform that has some specific features are brought directly to you. So you have them right in Unity. But for all the common things, you don't have to worry about the differences between those platforms. So that's the first thing. Next, we are introducing in 19.1 a set of features. The first one is the possibility to record a session. So if you are playing with your app that you've built and exploring the world, you can record all the events that happen and replay that session and use it, for example, as the test script for further testing, for further test if you've made some changes to verify everything is OK. Next, in 19.2, we're working on editor simulation. So in this case, you don't even need to have a device connected to the Unity editor. You can actually simulate inputs and a real world around you. So again, that's a way to iterate really fast even without having a device connected. So I skipped the AR remote because I have a video. So the AR remote is a way to combine the power of the Unity editor and having a phone connected to your development machine. So in that case, the way it works, you connect your phone to the Unity editor, and then the phone is streaming the world to the editor and all the information, location, plane detection, and everything. And so you end up basically working directly in the editor, but you have the phone that is acting as a device capturing the world. So you can iterate really fast and test and do a lot of testing without having to build and then wait for the build to be ready and play with the phone. So we can really combine that, and that's super powerful to iterate very fast. So let's talk about graphics. As I said earlier, Unity was created more than 10 years ago. And when we made the first iterations of Unity, we've built a really powerful graphics engine, but we also built it in a way that's a fairly black box, in the sense that there's not a lot of hooks to tweak it to really get the engine to go in the direction you want. So a couple of years ago, we started thinking about a new rendering engine, and we built this new engine with the idea that we want to give you a lot of power, a lot of control, and also a lot of flexibility. So what we've done is basically created a core of the rendering pipeline that is built in C++. And around that core, we have a series of scripts that are written in C# that will take care of all the steps that are happening in the rendering pipeline. So that we give you full control of the rendering pipeline, but on the other hand, your responsibility is limited to writing code in C# and having to choose the different steps you want. So you can have a customized rendering process, you control resource usage, you can control performance. And that is all and great for people at Francesco who likes to create rendering pipeline. But out of the box, we give you 2 rendering pipelines that are ready to use. And the first one that we call lightweight render pipeline is actually out of preview, so final in Unity 19.1. And this is basically the more universal pipeline that is designed with performance in mind, and that will work really well across all platforms. There's a big focus on making that pipeline super efficient on mobile, but also it's really easy to configure this pipeline to add extra post-processing or to remove post-processing or to add your custom steps if you want to do special things during the rendering pipeline. So this is the one that is really recommended for mobile. And we have another rendering pipeline, which is called high-definition render pipeline, which is basically the one we use for games that are designed to run on PC console exclusively. That's the pipeline that is used in film when we want to do simulation. So Unity has been used to do, we've shown some demo to show a Lexus car in a world that you don't even know if it's a real one or a fake one. And that's the rendering pipeline that's being used for those. And the main difference is that the high-definition render pipeline is actually heavily relying on GPU compute processing, which is somehow available on mobile, but not on all mobile for sure, and even on high-end mobile has some limitation. So to drill down a little bit on the graphics roadmap, specifically for what applies to mobile, there's a few features that I wanted to discuss today. The first one is one we call dynamic resolution, which is available for the lightweight render pipeline now. And what it enables you is basically at runtime, you can decide to reduce a little bit the resolution at which you are rendering so that you can really save on bandwidth on the GPU, on the CPU, and on memory. And you just reduce by a few percent your resolution, and you blip to the full screen at the very last step. And this feature requires us to use Vulkan. I wanted to mention the fact that we've been working a lot on Vulkan with Google, with all the OEMs, to make sure Vulkan gets better and better. And so with 19.1, actually, by default, when you create a new project, it's going to be Vulkan, the primary graphic API that is selected. And of course, you can decide to choose something different. But we truly believe that Vulkan is at a stage where it is seriously a good solution, especially for the latest devices. I wanted to mention also a feature that is called optimized frame pacing. And that's a feature that actually has been developed by Google that we've integrated inside Unity. So what it does, basically, it provides a better orchestration of the distribution of the frames during the cycle of generating the frames for the game. And Android is a pretty complex operating system, and this feature makes your game frame rate even more smooth. And so that's, for me, the opportunity to highlight the partnership that Unity and Google have been having for years now. And then really, we work super closely to make sure Unity works well on Android, but also Google is listening to us, game engine creators, with the input we can give to their team so Android gets better over time. So it's really a rich collaboration, a rich discussion, and hopefully you'll get the benefits as game creators of all those collaboration. And I wanted to finish on shader graph. So you mentioned you like to write shaders. I hate, actually no, I can't write a shader. I can't, I'm sorry. I used to be a developer, but shaders is out of my league for many reasons. First of all, it's pretty advanced math. And you have to have that capability of seeing the pixels on the screen and translating that vision into code and math. This is really hard. Some people can do it, most cannot. And of course, from a productivity standpoint, writing a shader by hand is not the most productive. So we have created this new tool, Shader Graph, which is out of preview with 19.1, that really enables any artist to combine, using a node graph-based system, a bunch of steps. And it's a big toolbox with a lot of options, but it's really super easy to use. You can, on this screenshot, you can take a model and put it as the output, the end result, and then you combine all the different nodes to create the effect that you want. And in 19.1, we've added one feature, which is nestable graphs. So if you end up having a giant graph, then you can actually create subsections, make them a subgraph, and then just connect them with the rest of your graph, which makes it much more readable and also makes some parts reusable. In 19.2, we are introducing the half precision toggle. For example, in a scenario where you're planning to make a game that will work not only on mobile, but also on PC and console, you actually want half precision shaders on mobile and then full precision on bigger platforms. But right in Shader Graph, you can actually switch that toggle so you can see the effect of changing the precision level on your shaders. So visually, you get the result to see if that changing that precision is not going to create any trouble. And much more is coming. At the end of the slide, we have a little video with a series of cool games made with Unity. But with that, I'll take it away. Ben? Thanks.
All right. Thanks, GC. Hello, everyone. My name is Ben Gable. I'm a developer advocate here at Google and game developer. I work with game developers every day to help them make awesome games on Android. And I'm here today to talk a little bit about Android app bundles. And specifically for Unity developers, how you can utilize this awesome tool and how you should totally be using it on your production games. So to start off, I wanted to kind of get a quick show of hands. How many of you are familiar with Android app bundles? OK, that's a good number. And of those people that are familiar with it, how many are actually using Android app bundles instead of an APK? OK, there's a lot less that time around. So hopefully at the end of this talk, there's a lot more hands that will go up in the near future. So what is an Android app bundle? So Android app bundles are an awesome tool that save you from having to manage multiple APKs or from having to kind of put all of your stuff into one APK and keep it under some kind of size limit to support all these different device configurations. So for example, you either have to have multiple APKs, one for the different architectures that are out there, x86, ARM. You might have multiple APKs for high-resolution assets, and an APK for low-resolution assets. Or you're trying to fit all of that together into one universal APK that fits all devices. And so what app bundles let you do is instead of building these multiple APKs or fitting it all into one, you build an app bundle, which has everything needed for your game to run across all these different devices. And then instead of uploading an APK to Google Play, you upload the app bundle. And what Google Play is going to do on the back end is basically take your app bundle, and it's going to generate and sign and distribute an optimized APK specifically for the device that somebody's playing on. So for example, if somebody's coming along and they want to download your game on an x86 device, they're only going to get the x86 versions of your native libraries, and they won't get the ARM versions there. So it saves a lot of space on the user's end as well. And another cool aspect of Android app bundles is that right now on the App Store on Google Play, if you upload an APK, you have to keep it under 100 megabytes unless if you're over 100 megabytes, you have to use expansion files. With app bundles, you can actually, we've increased that limit to 150 megabytes. So there's a lot of benefits to using app bundles, and I'm here to specifically show how easy it is in Unity to do this and why you should be totally using it. So the idea behind app bundles is all of these benefits and saving you the hassle of managing all these multiple APKs with none of the overhead. So if you're using Unity 2018.3 and above, app bundles are super simple to build. I'll show you in a second. Or if you're potentially exporting to Android Studio, if you're using Android Studio 3.2 and above, it's just the build option to build an app bundle instead of an APK. So in Unity out of the box, what you're going to get, as I mentioned before, is when you build an Android app bundle, Unity is going to generate it, and it's going to allow you to basically provide optimized builds for different native library and running on different architectures. So you're going to get 64 and 32-bit ARM support, as well as x86 native library support. Now, you can also, if you set up your game to have your localization files in kind of the standard layout, you can use a post-build process to also build those files into your app bundle, such that if somebody's playing in Spanish, they'll only get the Spanish localization files and vice versa. That's not supported out of the box yet in Unity, but it's easy to do after the fact. So as I said, in Unity, it's super simple. You just, in your build settings, you just click that box right there, build an app bundle. Unity's going to generate the app bundle, and you can upload that directly to Google Play with no extra work required on your end. If you click build and run, what Unity's going to do is it's going to generate that app bundle, and then it's going to generate a temporary APK that you can test locally on your machine or with a device that's attached. So again, you're not losing that fast iteration process. It all just magically works. Now, I kind of mentioned something about the size limit increasing from 100 megabytes to 150 megabytes. And Unity actually goes above and beyond and gives you a really awesome size warning tool. So what you can do is you go into player settings, and you can enable this size notification. And what Unity is going to do is if it detects your app bundle is going to be over a certain threshold that you define, it's going to warn you and suggest to basically generate an APK from that app bundle, and you can be able to view what the size of that compressed APK is generated from the app bundle. So it's a really great tool to kind of keep you aware of any size limits you might be going over for your game. Now, another great tool with app bundles is once you upload the app bundle to Google Play, inside of your Play console, there's a new section called the App Bundle Explorer. And so you can see here the screenshot is of an app bundle that I uploaded, and I'm taking a look at it. And it shows you a lot of information about what your app bundle is currently configured, and things like the amount of size that you're saving using app bundles compared to if you just uploaded an APK. And you can see here it's going to show all the different APK configurations that this app bundle is set up to generate. So here I've basically set it up such that the app bundle will be able to generate APKs based on different screen densities. So again, if somebody downloads the game on a high-density screen, they're only going to get the high-resolution assets and nothing else. Now, as you've seen, it's really easy in Unity to build app bundles. If you have a custom build pipeline or something, it's also really simple to use Gradle to build an app bundle as well. However, there's another tool called Bundle Tool, which is an amazing product you should check out. So it's available on GitHub, or it actually comes with your Unity editor installation. And what Bundle Tool lets you do is you can use it from the command line in your custom build scripts, and you can generate an app bundle. And then additionally, what you can do with Bundle Tool is you can use it to generate APKs from that app bundle for specific device configurations that you might want to test on. So you could generate APKs from your app bundle to send to your QA team, to your automated testing solutions. So it makes it really, really easy to, again, get all the benefits of using app bundles while at the same time not increasing your overhead of having to generate both app bundles and APKs for testing. So it's really simple. And another really key tool to use with Bundle Tool is that if you happen to be distributing in a region where the Google Play Store is not available, or if you're distributing on a store that does not support app bundles, Bundle Tool, you can add one extra step to also generate a universal APK from the app bundle you've generated, such that you can then use that APK on the stores where the app bundles are not supported. So again, super easy to do and not a lot of overhead to get the benefits. So that's my little bit on Android app bundles. I hope you guys take a look. There's a lot more information on the Unity documentation as well as the Android developer documentation. So now I'm going to hand it back off to Fran to finish off with some of the plugins that we've built for Unity for Google Play Feature Store support. Thanks.
Thanks, man. And some of the plugins are, one, Play Instant. We talked at length just before this talk about Play Instant, so I'm not going to go through it anymore. In a nutshell, is if you create a game that is less than 10 megabytes of the big game you have, you can run it very, very fast and basically run it straight off a URL, which is awesome. It's a great experience. To do it in Unity, we provide the Play Instant plugin, which basically is as simple as the screen. You say you want to generate an instant build out of your big Unity game. And off it goes. It does everything that you normally would have done manually to generate an APK that you can upload straight into the Google Play Instant track on Google Play. Google Play Instant was my first job here at Google 2 years ago. I'm pretty new still. And I work with my very good friends here. They're here on this game, Panda Pop from Gem City. This is a hilarious story here. I was my first job here at Google. I was having a meeting with Vanessa from Gem City, and then I went back home, and my kid was playing, he's 3 years old, with Panda Pop. Talk about bringing work home. So I took a photo of him playing with Panda Pop, sent it to Vanessa. She was like, oh my God, that's so cute. She sent him a plush toy with a panda. My kids still use it to go to sleep. And then he sends back to Vanessa a video, thank you. And then now my kid is 5 years old, and he's having regular breakfast, business breakfast with Gem City. It's like he's fast-tracked into the game industry. I hope he doesn't follow me. But making this game, this is a Unity game, was pretty straightforward, even if it was literally the first ever Unity game to be released an instant. And it was a great experience. Now we're going to show you a bunch of games. This is a video about a minute. A bunch of games made with Unity. I work with at least one of the games here. And here's the video. Cool. That's it, we're done. Thank you.